some characteristics of covalent compounds are they have low melting and boiling points in comparison to ionic compounds. Most are going to be powders, liquids, or gases. In other words, they're not going to be strong solids. They do not conduct electricity in any form in comparison to ionic, which conduct it in its liquid or molten, and aqueous or dissolved forms. And they exist as discrete molecules instead of positively and negatively charged ions, such as in ionic compounds. So they're going to stay together. And they're insoluble in water most of the time. Insoluble meaning will not dissolve. To draw the Lewis structure for covalent compounds, we're going to go through the list that's on your notes using the example in the bottom left. So our first example is PF3. The first thing we need to do is add up the total number of valence electrons in PF3. So P has 1, 2, 3, 4, 5, and fluorine has 7. So we have 5, and then 7, but we have 3. So 7 times 3 is 21, plus 5 is 26. So we have 26 valence electrons. So that's how many electrons we have to make sure that everything has 8. Then we decide which atom is the central atom. This is the atom that's present in the fewest number, or the least electronegative, if you have two that have the same number. Hydrogen can never be the central atom because it can only have 2 electrons, which is 1 bond. In other words, it's not going to be able to make 2 bonds to be the central atom. So in our case, we have P and F. We only have 1 phosphorus, so phosphorus would be our central atom. If we had equal amounts of P and F, then we would have to look, and electronegativity goes up and to the right, so we want the one that's further left and down. P is less electronegative, so it would also be in the middle if we had equal P's and F's. Next, we're going to hook the peripheral atoms to the central atom with covalent bonds and subtract 2 electrons from the total of the valence electrons. Peripheral atoms are just the other atoms that aren't the central atom. So we have 3 fluorines. We started with 26 electrons, and each line is 2 electrons. So we need to subtract 6. So each of these lines is 2 electrons. If it helps, you can add the electrons on the line like I did there so you can see the electrons. So that's 2 electrons for fluorine and 2 electrons for phosphorus. So right now, this fluorine only has 2 electrons. Then we're going to fill the octets, with the exception of hydrogen, which can only hold 2 electrons, of all the peripheral atoms. And then the other electrons will go on the central atom. We'll need to also make sure that our central atom has 8. So basically, we are making sure that everything has 8 electrons, regardless of how many it came in with. So fluorine currently only has 2, so it needs 6 more electrons to have 8. This fluorine also has 2, so it needs 6 more. This fluorine has 2, so it needs 6. And phosphorus currently has 6 electrons, so it needs 2 more. So 6, 6, 6, and 2 is 20 electrons. We have 20, so we're going to add them as lone pairs. So before moving on, always double check that you've only used 26 electrons. No more, no less. So I've used 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. And that everything has 8. This fluorine has 2, 4, 6, 8. This fluorine has 2, 4, 6, 8. 2, 4, 6, 8. And then phosphorus has 2, 4, 6, 8. So the electrons between them go for both of them. So this is the Lewis structure for PF3. We'll go through rules 6 and 7 more in future examples. So let's look at another one, carbon tetrachloride. First, we have to write our equation because it wasn't given. So we only have one carbon, tetrachloride, 4 chlorines. So now we look at our valence electrons. Carbon had 4, chlorine has 7, but we have 4 of them. So we have 32 valence. We only have one carbon, so carbon has to go in the middle. Chlorine's coming off. So we subtract 2, 4, 6, 8. 32 minus 8 is 24 electrons left. So we have 24 electrons to make everything have 8. Currently, chlorine only has 2. It came in with 7, but it wants 8. So each chlorine needs 6. And then carbon already has 2, 4, 6, 8. So carbon is good. So we only need to worry about our chlorines. Each needs 6, and we have 4 of them. 6 times 4 is 24. So I can just add my 24 electrons as dots. Double check that we've used 32, which we did, and that everything has 8, which it does. But again, in case you didn't see it, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. Don't forget about that central atom. It has 2, 4, 6, 8 as well. Before moving on, we need to go over some vocab. These dots are referred to as lone pairs of electrons, or non-bonding pair of electron. So if it said how many lone pairs are in this molecule, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we would have 12 lone pairs. These lines are referred to as bonding pairs of electrons. So if it asks how many bonding pairs of electrons, we have 4 bonding pairs of electrons. 1, 2, 3, 4 bonding pairs of electrons. This one's a little tricky. Make sure that you're not working ahead as we go through many examples of exceptions throughout the notes. So ethane is C2H6. First, I figure out my valence electrons. I have 2 carbons, each have 4. And I have 6 hydrogens, each with 1. So that gives me 14 valence electrons. Out of carbon and hydrogen, hydrogen can't go in the middle, so carbon is going in the middle. But I can't have carbon with everything else coming off of it, because that would be 2, 4, 6, 8, 10, 12, 14 electrons on carbon, and carbon can have 14 electrons coming off of it. So instead, when you have a hydrocarbon, which is carbon and hydrogen, we're going to hook them together. So we have 2 carbons in the middle, and then the hydrogens will come off symmetrically. So I have 3 hydrogens and 3 hydrogens. I need to subtract how much I've used. I've used 2, 4, 6, 8, 10, 12, 14. So minus 14, I have 0 left. Well, each hydrogen only has a line, but that's all hydrogen can have is a bonding pair of electrons because it can only hold 2 electrons. And each carbon has 2, 4, 6, 8. And 2, 4, 6, 8. So my carbons are also good. So this is the structure for ethane, or C2H6. Nitrogen gas's formula is N2. We'll talk more about why it's N2 on second semester. So nitrogen gas is N2, and each nitrogen has 5 valence electrons. Therefore, we have 10 valence electrons altogether. So in this case, we only have 2 elements. When you only have 2 elements, you don't have a central atom. They're both going to just be hooked together. We drew one line So we have 8 left. This nitrogen needs 6 more. And this nitrogen needs 6 more because they both currently have 2 because of that line counts for 2 electrons for both of them. So we need 12 electrons, but we only have 8 electrons left. When you need more than you have to share more. We share more by adding another line. So now we have a double bond. Since I drew another bond, I need to subtract 2. Now this nitrogen has 4, so it needs 4 more. This nitrogen also has 4, so it needs 4 more. So I need 8. I only have 6 though. So again, I need more than I have, so I have to share more. So that's going to give me a triple bond. The largest you're going to see is a triple bond. There are no quadruple bonds. So if you've gone past 3, you've done something wrong. So subtract 2 again. Now I only have 4. This nitrogen has 2, 4, 6, so it needs 2. And this one has 2, 4, 6, so it needs 2. Now I need 4. I have 4, so I can just add them as lone pairs. Again, always double check. 2, 4, 6, 8, 10. I've used 10. And 2, 4, 6, 8. 2, 4, 6, 8. Everything has 8. So this is the structure for nitrogen gas. So first we need to write our equation. Beryllium and chlorine. So beryllium chloride is BeCl2. This does start with a metal, but beryllium always covalently bonds. So of the 2, we only have 1 beryllium, so it's going to go in the middle. Chlorines come off. For my valence electrons, beryllium has 2, and each chlorine has 7. So that's 14 plus 2 gives me 16. I'm going to subtract 4 because I drew 2 lines. This chlorine needs 6. This beryllium needs 2, 4, so 4 more. And this chlorine has 2, so it needs 6. So I need 16, but I only have 12. So we would have to double bond. But we look back in our notes. So in Rule 6, it says, if the central atom does not have at least an octet, and the central atom is not one of the exceptions to the octet rule. Boron or beryllium. Boron and beryllium are exceptions to the octet rule, which means we do not double or triple bond boron or beryllium. They rarely have 8 electrons. Boron bonds with 3 things, so it usually has 6. And beryllium will bond with 2 things, so it generally only has 4. So they double the number of electrons they came in with, but they don't get 8 electrons. So boron and beryllium, as well as hydrogen, will not get 8 electrons. So in this case, if we don't care about the central atom, then we have 12. We need 12, so we're just going to add them as lone pairs on chlorine. And then I've used 12. I've used 2, 4, 6, 8, 10, 12, 14, 16. Everything has 8 except the central atom, which in this case is beryllium. But again, if that was carbon in the center or nitrogen in the center, it would have to have 8 electrons. Only because it's beryllium are we leaving the central atom with 4 electrons. This one, arsenic pentabromide. We have prefixes, so we should be able to write our formula. Arsenic has 5, and bromine has 7. So 7 times 5 is 35, plus 5, we have 40 valence. In this case, arsenic is going to go in the middle, and bromines are going to come off. Currently, the central atom has 2, 4, 6, 8, 10. Arsenic can have 10 electrons, though. Because arsenic is in the the fourth energy level. Anything in the third energy level or down, so the fourth energy level, fifth, can have more than 8. They don't want more than 8, but if it takes 5 bromines to bond with it in order for it to get a stable octet, then that's what it's going to do. The reason arsenic can have more than 8 is it's going to fill up its electron configuration is argon, and then 4s2, 3d10, 4p3. So it's going to put its empty electrons or its extra electrons in the 4p to fill that up. So generally we're filling up the s and the p. That gives us 8 electrons. But arsenic has a 4d that's currently 0. So those extra 2 electrons, it's going to stick them in its 4d. NBr5 can't exist because nitrogen would fill up its 2p, and there is no such thing as 2d. It would have to stick them in the 3s, which is another energy level, and that can't happen. So that's why the third energy level and below can have more than 8, because the third energy level is where that D starts. And it'll always be empty if we're over here. So phosphorus has an empty 3D. Arsenic has an empty 4D. So that's where it's sticking it. For right now, it's not so important that you know where everything's going, but you should know that these elements cannot have more than 8. But everything else can have more than 8. But again, you should not go double or triple bond crazy just because it can have more than 8. So we drew 5 bonds, so that's 10 electrons. We have 30 left. Arsenic currently has 10, so that's plenty of electrons for arsenic. Each bromine has 2, so it needs 6 more. 6 times 5 is 30. We have 30 electrons, so we should be able to add them as lone pairs. And so that's the structure for arsenic pentabromide. Go ahead and pause the video and try this one on your own. Restart when you have an answer. If you have CO2 and 16, then continue the video. If you do not, pause and fix your structure. So this is my general structure, and I have 12 electrons left. This oxygen needed 6, carbon needs 4, and oxygen needs 6. So I currently need 16 to fill it up with lone pairs. I do not have 16 left, I only have 12. So I needed a double bond. I do one double bond at a time. You do not have to add these numbers at the bottom. I'm just doing so you can see where I'm getting how many electrons I need. If that's a good visual for you, then you should also do that. So this oxygen still needs 4, carbon needs 2, and this oxygen still needs 6, so that's 12, but I only have 10. So now I'm going to double bond both sides. Now this oxygen needs 4, this one needs 4, so I need 8. I have 8, so now I'm going to add them as lone pairs. Make sure I've only used 16, 2, 4, 6, 8, 10, 12, 14, 16, and that everything has 8, which it does. So this should be your structure for carbon dioxide. Ammonium ion is a little bit different. The first thing you have to do is write your formula. Ammonium is one of your polyatomic ions, so NH4 plus 1. So when it's an ion, you have 2 things that are going to be different. First, you're going to add up your valence electrons. Nitrogen had 5. And each hydrogen had 1. So that gives you 9. But it's a positive ion. Positive ions mean you lost electrons. And in this case, I lost 1 electron. So I only have 8 valence electrons to work with. If it was a negative ion, I would gain that number and put it on my total number of valence electrons. So I have 8 to work with, and I have nitrogen and hydrogen. Nitrogen has to go in the middle, and hydrogens are going to come off. I'm out of electrons. So I've got to double check. Nitrogen has 2, 4, 6, 8, so that's good. And each hydrogen has 2, which is all it needs. No dots on hydrogen. So I'm done. The other thing that you must do if it's an ion is you have to put brackets and put a charge on that molecule. So the entire ion should have brackets and a charge. Otherwise, it would look like you should have 9 electrons, and then you're like, where's that last electron at? So with an ion, add or subtract from total valence and bracket and charge it. I'm going to pause the video and draw the Lewis structure for water, restarting when you have an answer. So water should have been H2O. And you should have had 8 valence electrons. Oxygen should have went in the middle. Hydrogen can never go in the middle. We had 4 left. Remember, hydrogen never gets dots. So no dots on hydrogen, and oxygen still needs 4. We have 4, so we just add them as lone pairs. And that should be your structure for water. Everything has 8. Except hydrogen, which only ever needs 2 electrons, so the line suffices for hydrogen. I'm going to pause the video and draw sulfate ion on your own. Restart when you have an answer. So sulfate is SO4 -2. Sulfur has 6. Oxygen has 6 valence, so 6 times 5 is 30. And it's a -2, which means I need to add 2. So you should have 32 valence. If you messed up on your valence electrons, pause and redraw your structure. Sulfur should have went in the middle. Oxygen's coming off. So we have 24 left. Each oxygen needs 6. 6 times 4 is 24. And sulfur is good. So now we can just add them as lone pairs. Don't forget to always bracket and charge it. So if you left your bracket and charge off, you're not going to be getting full credit, so make sure that you do so. And so that's sulfate ion. Last thing is if you ever have extra electrons, 1, make sure that you didn't miscount, but occasionally you will have extra electrons, and those will go on central atom. Assuming the central atom is in that 3rd energy level or 4th energy level or 5th energy level. If it's in the 2nd energy level, there's nowhere for them to put it. So then you've probably messed up. So 3rd or higher can have extra electrons, and they'll go on central atom.